Hello everyone, Mr. Minix, my name, math is my game. I'm really stoked today if you can't tell. I hope I sound like a rock star. I got this new microphone and I feel like a rock star with it. It's lightweight, it's got a rubbery handle and anyway, I like it. Today I'm joined by my first period Algebra II class. You can tell how stoked they are to be a part of this. So the title, Chapter 6, Section 5, Solving. So that means we're going to get solutions. So that means we're going to say the variable, probably x, sometimes y, equals something. Solving square root and other radical equations. I wish I could do a skater accent, but I can't. I think my partner in crime could. Dr. Jones, might have to have him make a cameo appearance in this to do some skater talk. Anyway, the objective, the goal, by the end of this lesson, if you're asking yourself a question, you should be able to say, self, can I solve a square root equation? Can I solve some other radical equation? Common Core content standards, you don't need to write them down, but you're supposed to be able to solve simple, rational, and radical equations in one variable and show how extraneous solutions may arise. Rearrange formulas to highlight a quantity of interest, blah, 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 blah. Okay, let's get to it. Really, as far as notes go, I don't have much to tell you other than this. There's a big E word. It's called exponentiation. Exponentiation. Okay, all that means is raising something. Raising something, kind of like yeast does to bread dough. Raising something to a power, though. Well, maybe it's not the same as what yeast does to bread dough. But exponentiation, we're just going to be exponentiating things. That's it. That's it. It's that easy. Sometimes we might have a little housekeeping to do. Suppose I had something like x to the 3/5 power, and I wanted to exponentiate this so that I could turn that x variable into x to the 1st power. In this section, you're going to have to be able to come up with an exponent to which we could raise x to the 3/5 to make it x to the 1st. I haven't told you how to do this, but we did talk about fractions before. We did talk about powers of a power. A power of a power is the product of the powers, right? So, for 5 bonus quiz points, who can tell me what power? What do we got? Nice, right on, 5/3, good. If we exponentiated this to the 5/3, it would be x to the 3/5 times 5/3. And 3/5 and 5/3 are each other's reciprocal, and if you multiply something by its reciprocal, the 3's cancel, the 5's cancel, and when stuff cancels like that, it's x to the 1st. So good. So in the end of this, we're going to have equations like that, where we're going to have to exponentiate something to a reciprocal power. I know we're using some big words here. I could say to the flippy thingy power. Okay, let's just look at some examples. Problem number 1. It reminds me of math, people. How come math teachers don't have many friends? Because they have too many problems, and they like to share them with their friends also. So this problem here reminds me of spending the night at the hotel for 2 days in a row. 2 days in a row at the hotel. 11 o'clock the next day, what do they say? What's that? Room service? Not room service. Room service, man, that's expensive. I drive uptown and get a pizza or McDonald's. Unless I'm in Jefferson. I won't go to Jefferson McDonald's again. They charge me 60 cents for a squirt of mayonnaise on a cheeseburger. That's ridiculous. Anyway, maybe it was Conneaut, somewhere up north. What happens at the hotel? 11 o'clock the next day. Housekeeping. What I mean by this is we need to get the radical stuff, the radical expression the stuff that looks like a rat, this. We need to get that all by its lonesome. So if we had to get that all by its lonesome, what's the first thing we ought to do? Subtract 3. Sure, let's take away 3 from both sides. So we subtract 3 here, subtract 3 here. That's going to leave us with a square root of 2x, take away 3, and that's equal to 5. Muy bien. Now we want to know what x equals. We don't want to know what 2x minus 3 equals. But before we can get 2x minus 3 by itself, before we can get this expression by itself, remember ultimately our end goal, our end aim is to get the x by itself, but before we can do that, we got to get rid of that square root. So we're going to be exponentiating each side to what power? What power are we going to be raising both sides to? To make the square root go away? To the second, right? We're just going to square both sides. We're going to square this, we're going to square this. On the left, when we square a square root, the square root goes away, right? Okay. So on the left side of the expression, what's left? 2x minus 3. And on the right side, we get 5 squared. What's that? Oh, yeah, 25. Okay, good. So we're almost home. From here, I would expect that at this point in time, you would know that you add 3 and then divide by 2. So we get 28 divided by 2, and our final answer for x is? X equals 14. Muy bien. We could check it. 2 times 14 is 28. 28 minus 3 is 25. Square root of 25 is 5. 3 plus 5 is 8. It checks out. It's good in hood. There's a lot of expressions I use that some people don't get, like the city juice. Anybody know what city juice is? It's what 70% of your body's made up of. Yeah, water, H2O, city juice. Okay. Let's try Godding. Let's try this Godding example. Square root 4x plus 1 minus 5 equals 0. What should we do first? Add 5 to both sides. I like to move it. So we get square root 4x plus 1. That equals 5. And then what? Square each side. Good. So we get 4x plus 1 is 25. Subtract the 1, divide by 4. Final answer, x equals 6. Muy bien. 4 times 6 is 24. 24 plus 1 is 25. 25 square root is 5. 5 minus 5 is 0. That's good. Now, at some point in the future, you all are going to be taking an exam, a test, on which you'll be allowed to use the TI Inspire. Do you think the TI Inspire will solve these for you? It will. It's going to take a minute to load. Does anybody remember the name of the command that we use on the TI Inspire to numerically solve an equation? Nsolve. You just type in nsolve, you type the equation. What do you put after the equation? Comma, the variable, and usually we use x. Good. Right on. Right on. Does anybody know why? I went on a train ride the other day ago. Does anybody know why the train operator was struck by lightning? Because she was a good conductor. That was bad. I got an even worse one. It might offend some people. It's about, no, maybe I better not. It might touch home to, it might have happened to somebody. Has anybody in here ever lost a family member to a skydiving incident? Because I don't want to hurt anybody's feelings. If you have, I'm not going to tell it. Okay. What's the difference between a skydiver and a bad golfer? Well, between a bad skydiver and a bad golfer. One says, whack, darn, and the other goes, darn, whack. That's really mean. I don't take responsibility for that one. You all wanted to hear it. I might have to edit that one out. Okay, menu, add calculator, and solve, parenthesis, the square root of 4x plus 1 minus 5 is 0, comma, x. Bam, look at that, like a boss. All right. Oh, problem 2. This is good. This is awesome. 3 times the quantity x plus 1, the quantity to the 2/3 equals 12. Again, this one reminds me of the hotel. You probably know why. What should we do first? Divide by 3, right? Divide by 3, divide by 3. So this leaves us with x plus 1, the quantity to the 2/3 power, and that equals how much? 4. Okay, fine. So remember, this whole section is about doing what? It's about exponentiating. So we're going to exponentiate both sides to some power to the power of 3 over 2. Now, at this point, you're thinking, dude, I don't know what 4 raised to the 3 over 2 power is. But you do know that raising something to the 1/2 is like taking something's square root, right? So what ends up happening here, on the left side, we get x plus 1. On the right side, we have the square root of 4. And what happens with that 3? Because the 2 right here, that 2 is that index for the square root, right? So what happens to the 3? The 3, where's that 3 go? It's going to go on the 4 as its exponent. We could put it here, or we could put it out here. Either way, I think we could evaluate that expression either way, right? 4 cubed is 64. 64 square root's 8. 4 square root is 2, and 2 cubed is 8. So no matter how we shake that one down, we're going to get 8 out of that. So we end up with x plus 1 equals 8. And so our final solution is that x equals 7. Remember, when we do these, we probably ought to check. 7 plus 1 is 8. 8's third root is 2. 2 squared is 4. 3 times 4 is 12. It checks out, and we got him. I would expect you to be able to do one of those without a calculator. You think we could handle that? Okay. Any questions up to this point? Because I've got news for you. Somebody always asks the question. These are easy. Does it get more difficult? Clearly. Clearly it will. Sometimes when you do math, you end up running around in circles. Anybody ever drive around in circles? You're trying to find a place and you drive like 20 miles, but you don't go anywhere. You're like, dude, I saw that same stop sign like 17 times in the last hour. Anybody ever do that? Wait till you do someday. It's horrible. Well, now you have GSP. Oh no, that's that. Oh yeah, I just wanted to say GSP. Is that George St. Pierre, or who is GSP? Is GSP a wrestler or a UFC person? I'm thinking PLG. I'm getting all my French Canadian athletes mixed up. I'm thinking PLG. Isn't that the skateboard guy? Pierre-Luc Gagnon? He's not a skateboard guy? PLG? He's a bike guy. That's it. He's a bike guy. PLG. Okay. Maybe I don't know. Anyway, yeah, sometimes you run yourself around in circles, and that's going to happen at some point, but not yet. It might happen here. It might happen here. Do you see the directions, what they say? Check for extraneous solutions. Sometimes you run around in circles, and sometimes you do some really good work. Sometimes you do some really good driving, and you end up with something that doesn't satisfy the original equation. We might get 2 answers here. And if we do, one of them might not work. I know, right? So let's see. Housekeeping. Would it hurt anybody's feelings if I put this x plus 7 on the right and then took this? I'm going to be adding 5, right? So I'm going to have x plus 5. Would it hurt your feelings if I took that x plus 5 and wrote it on the left? Okay, I'm going to do it that way. X plus 5 equals the square root of x plus 7. Okay? Hopefully you kind of see what I did there. I basically more or less used the reflexive property. Okay? So what are we going to do to both sides? We're almost done here. What are we going to do to both sides? We're going to exponentiate them. What power are we going to raise both sides to? To the power of 2. Okay. To the power of 2. Okay, fine. Now I know that everybody in the world knows what the right side is. What's the right side equal? X plus 7. I know that 66 and 2/3% of high school students are going to miss this. X squared plus 5 squared. That's what most people think. And most people forgot everything they learned about in chapter 4 and chapter 5 when you learned about expanding binomials and the binomial theorem. 5 quiz bonus points to the first person who could tell them. What do we got? Thank you. X squared plus 10x plus 25. If you don't understand why, go back to chapter 4. Go back to chapter 5. Realize expanding a binomial is more than just squaring the first and the last term. Okay. Hey, wait a minute. Didn't Mr. Jones spend like 7 weeks teaching you how to factor and solving quadratic equations and whatnot? So we're going to get x squared plus 9x. Where did I get 9x from? I subtracted x from both sides, right? And then 25 minus 7 is 18, okay? And so, oh, that's plus 18, okay? So I get x plus 3 and x plus 6, the quantity squared equals 0. So I think x equals -3, and I think x equals -6, right? I know I went really fast through that. You're probably going to have to watch that in slow-mo. You're going to be like, huh? All I did was factored, right? Teach me how to factor. Teach me how to factor. So I think that those are my answers, but the direction said check yourself before you wreck yourself, son. So -3 plus 7 is 4. Square root of 4 is 2. And 2 minus 5 is -3, and -3 equals -3. So the -3 does work. Got him. That one's good. -6. Let's see. -6 plus 7 is 1. Square root of 1 is 1. And 1 minus 5 is not -6, is it? So even though we did really good work, even though it seems as though we're too legit to quit, this solution here, this one right here, this is called extraneous. What that means is it's a byproduct of some really good work, but it's unnecessary. It's kind of like that one part of the birthing process. Yeah, we don't need it. It's extraneous. It's not a solution. It doesn't work in the original equation. So you're probably asking yourself, how could I be sure? How could I be sure? You could do what? How about we graph it? How about we go to a graphing page on our calculator and we graph this. Square root x plus 7 minus 5. Square root x plus 7 minus 5. Do I want to do this in 2 functions or 1? 1? Okay. So what I need to do then is I need to go ahead and subtract that x so everything's all equal to 0. Everybody see what I got going on here? What am I looking for if I do this in 1 function? The solution to this is where the graph does what? Intersects the x-axis. If I did 2, it would be where the 2 graphs meet, the x-coordinate, right? So I'm looking for an x-intercept. There's an x-intercept when x equals what? Negative 3, is there one when x equals negative 6? I don't think so, Tim. Menu, analyze, uh, 0. Left bound, right bound, there it is. Negative 3 is our only solution. Got him? What happens when x equals negative 6? Can I go to my table? Control T for the table. When x equals negative 6, when x equals negative 6, that whole expression ends up being 2, and 2 is clearly not 0. So anyway, that's it. Any questions, comments, concerns, short debates, long debates? Mr. Jones, you want to make a cameo appearance and go over the title of this? Those equations that are like radical and whatnot? Or maybe we could have the former president of the United States' son make a cameo appearance. Okay. I'd like to give a shout out to the future Mr. Minnick. You're awesome. Don't let anybody tell you anything else. I'd like to give a shout out to anybody who's watching this BX at home. Good looking out. Okay, maybe we'll get Mr. Jones on the next one. It's been real. It's been fun. I'll see you next time. Good.